This video is entitled Protecting Information Resources and goes along with Chapter 5 of our textbook for BUIS 2100, An Introduction to Information Systems. I'm Dr. Renaud from Shawnee State University, and I'll be taking you through this presentation. In modern information systems, we're always concerned and fighting cybercrime, and cybercrime has a lot of different costs to a business organization. These costs can include lost revenue, stolen IDs, stolen intellectual property, and the biggest, lost trust and downtime. Because if we've had our clients' data stolen, including medical information or credit card information or other personally identifiable information, then that's a huge potential liability to a business. Now, there are several types of cybercrime that are cyber attacks or that you'll see. Spyware, which is secretly gathering usage and passwords and other things upon you. It's running on your computer maybe. Adware, which is used, it sits on your computer, and it doesn't really commit a crime, but it is kind of annoying because it gathers information, and it could gather fraudulent information about you or too much information about you. Phishing, which are emails that look real. The text of the email says, click here to order this, or we're your credit card company, you need to log into our website. But when you look at the origin, you look at the email addresses, you look at the servers that handled it, you can see that it's not quite right. Farming is where we actually create fraudulent websites. For instance, if you misspell Google, you might be taken to one of these fraudulent websites that looks like Google, but it really isn't. And that's called farming, where you set up these fraudulent to try to collect logins and password information and personally identifiable information. Baiting, is where a cyber criminal will say, well, here's a gift, here's this, here's this, here's this. We just need a little personal information from you. And it's often trying to get that last piece of information that they need to own you. Quid pro quo is a Latin phrase for kind of what that means, and quid pro quo means this for that. So, and it's usually in a negative connotation that quid pro quo is used. Smishing is mobile downloading of malware. Through SMS, through short messaging. So when you get a message saying, click here, you've got a package. I didn't order a package from Tasmania. I don't know what that link is. Probably going to try to download something on your phone. And vishing is using phones and voice to do the phishing attacks. Basically calling somebody and trying to talk them into something. So there are lots of different vectors and lots of different attacks and lots of different things that people are trying, and different ways that you're being attacked. There are a few other techniques that I wanted to talk about. One of them is called the keylogger. And basically what a keylogger does is it records every keystroke on your computer. Stop and think about it. If somebody was attached to your computer, either attached a little USB dongle, this isn't a keylogger, but it could be, that records every keystroke on your computer for me to go and get this piece of hardware off of your computer later, or had a piece of software loaded on your computer that was logging every keystroke, I would very quickly know your bank passwords, your user IDs, and all of those things, wouldn't I? And they can be hardware or software keyloggers. There's a technique called spiffing, where we capture network packets. For instance, maybe I plugged my computer into your network and I can see some network traffic floating around, and by analyzing that network traffic, maybe I can find user IDs, plain text passwords, and other things that would network addresses, those kinds of things that would give me a better vector into your system. And then spoofing is attempting to gain access by posting or by posing as an authorized user or application. So, well, that pretty much describes, but these are other techniques that are also being used in addition to the ones on the previous slide. So, with all of those techniques, what kind of crime and fraud are being done? Well, unauthorized use of a system and data, that would be something. A DOS attack, which I abbreviated DOS, it stands for denial of service attack. And basically what a DOS attack is, it's where a large number of computers flood your web server or your external network connection and cause it and bog it down to the point that normal users and real users and legitimate users can't use the service. So basically, someone has denied your service. Um, ID theft, stealing user IDs, passwords, social security numbers, and other identifiable information. Software piracy and intellectual property infringement. Cyber criminals can use these vectors for getting into your systems to distribute child pornography, to write viruses, to steal files and data, specifically for corporate espionage. Espionage. So, how about your competitor wants to know what you're working on? Well, maybe that's important. Changing records. These vectors could be used to connect into the servers to change your grades, or change other information like how much you owe, or those kinds of things. There are virus hoaxes that look like viruses but really aren't. And then lastly, the one that's made a lot of recent news been in the news a lot recently are ransomware attacks, where this piece of software will lock down the computers, lock down the databases, lock down the servers, and the company being attacked has to pay thousands, tens of thousands, and hundreds of thousands of dollars to these cyber criminals to release their data. Boy, that's a huge ethical problem, because if you pay them, that encourages them to do it. But if you don't pay them, how are you going to work? And do you have the disaster recovery? And we'll talk more about that in future slides here today. There are a couple of models that I want us to think about when we're thinking about cyber protection, about protecting our data and our systems. And one of them is called a comprehensive security system. And we're going to talk more about that in a future slide. But all of these basic safeguards need to be looked at using two different models. And one of them is called the CIA model. And the CIA model says, well, let's look at confidentiality, the authorized use of our resources, the integrity, the accuracy of our resources, and the availability of our resources. So we've kind of got this three-way tug of war game, because if we limit the confidentiality, we make it so confidential that nobody can see it, then it's not accessible. If we make it 100% accurate with no possibility for error, how available is it, and how confidential can it be? So this is kind of the three constraints that we're always fighting and trying to find somewhere in the middle. There's a guy called McCumber, who in 1991 kind of created a three-dimensional model, not just three goals pulling in a two-dimensional way, but he created a three-dimensional model that uses goals, the states of information, and different safeguards, and kind of put them on a Rubik's Cube, thinking about you can turn them and mix and match. But goals are confidentiality, integrity, and availability. Okay, so that's the CIA model as our goals of the system. Now, what states of the information? So as the information moves through your system, it's transmitted, it's stored, and it's processed. So at various states in transmission, we have to look at CIA. At storage, we have to look at CIA, and at processing, we have to look at CIA. And then he talks about the three kind of groups of safeguards that we all have to look at to make sure that we understand human factors, policy and practices, and then technology. So it's through humans and what we do, it's policies, practices, and education of humans and what we do, and then our cyber technology that we're doing. So that's what balances it all in a three-dimensional cube. I really kind of like that cube. It's a neat idea. So let's talk about some specific threats that you're going to see and that you're going to be fighting against on a regular basis. The first, and it's very common, is the virus or the worm. And a virus spreads through files, emails, network shares, and other ways of transmission. Basically, it attaches itself on the end of a file, either a Word document or an executable or some other kind of document, and then when you send it to somebody else, it goes and spreads and attaches to others. Lots of viruses on their own aren't horrible and aren't bad, but often they're tied in together with blended threats of the virus then brings in a rootkit or brings in a Trojan or brings in a logic bomb that then releases something later. So let's talk about a Trojan. A Trojan is a piece of malware, a piece of bad software that's hidden inside something a user wants. For instance, you get an email saying, hey, download this game. Well, you download the game, you run it, and it puts a piece of malicious software on your computer, piece of spyware, piece of adware, a piece of something else on your computer that violates network, that can potentially keylogger or something of that sort. Hopefully you've got good virus checker and malware software on your computers, and your network administrators maintain good tools in your email system to filter most of this, but there's always something new that you might not catch 100% of. A logic bomb is basically a piece of code buried inside of a program that releases a virus or a Trojan or a worm at a specific date and time or when a specific event happens. A backdoor. Programmers are humans. And programmers may add a little secret backdoor into a piece of software to allow them to maintain it without having to go through all the security processes. They're not supposed to. You tell them not to, but sometimes it was part of testing and never got removed. And once a malicious person, once a thief, a criminal, finds that backdoor, documents that backdoor, and publishes it, then you've got a problem. We talked about a blended threat. A rootkit. First thing, let me describe who root is. On a Unix or Linux or AIX or any of the X-based operating systems that exist, root is the user ID for the system administrator. So a root, I've got a T-shirt that says "Got Root," so I've got the system administrator account. So that's a rootkit. Basically, is a way to sneak in and break something, break a running process or some other vector in that lets you have remote access and execute files remotely on a server. So that's called a rootkit. And sometimes a virus or a Trojan will carry a rootkit or a keylogger or something else. A DOS attack, we talked about that in a previous slide, that a DOS attack is literally where your network is flooded from the outside and your customers, or even you, can't use the network. So basically they've denied your service, denial of service attack. Denial of service attacks often are a virus will go out and attack several computers, hundreds of computers, and at a certain date or time, all of those computers will start attacking you or attacking your network. So it's we call that a zombie farm or a botnet, where all of these computers have been taken over by a virus that then turns them into vectors that are banging on your firewall or on your web server and bringing your web server down. There's another term called cryptojacking, where the virus or rootkit loads a program that's mining cryptocurrencies on your computer for somebody else's benefit. So imagine if you had thousands of random people's computers working on mining your cryptocurrencies for you. You wouldn't have to have 1,000 computers to do it. You basically steal processing time and computer time and network time from lots of unsuspecting people. There's another threat that's not necessarily a cyber threat, but it's a really huge threat, and it's a threat of it's a technique known as social engineering. There's several great books on social engineering, including Kevin Mitnick's Steal This and some others. But social engineering basically, the concept is humans are stupid. Okay, most humans at least, and humans are gullible, and humans generally want to help other humans. So social engineering is using the human factor and attacking a cyber system, attacking a network, or attacking a corporate system or a database by getting credentials and getting in from other people. Dumpster diving is one of the techniques that's used in social engineering, where literally you dig through the garbage. If you collect enough garbage from an organization and enough paper with enough writing, with enough stuff on it, are you going to find pieces of paper with login credentials? Are you going to find pieces of paper with network paths? Are you going to find pieces of paper with descriptions of policies, practices, and other things? Shoulder surfing is another social engineering practice that malicious people will use, and that's basically watching over your shoulders. You type in a password. You type in a password and somebody watches you do it. They might not get all of the keys, but if you can see 80% of the keys, because most people's passwords are words and things, or numbers that are meaningful to the password, meaningful to the person, you can guess the rest sometimes. So shoulder surfing. Tailgating. Tailgating is, imagine you've got a gate to get onto a secure property. Well, tailgating is the gate goes up to let one car through, and two cars go through really close together. Tailgating, and that's often one way. A scareware, by having a piece of software pop up and say, well, how many times have you been on a website? You've gone to a dubious, not so great website, looking for a code or something, and it pops up this warning of the FBI has just taken over your computer. Click OK and download this fabulous piece of software. Well, there you go. See, it scared you into downloading something, or scared you into doing something. And then pretexting. Pretexting is not before you send somebody a text message. Pretexting is using a social pretext to get to them. For instance, you're sitting at your desk and you get a phone call. And it looks like it's coming from an internal extension, and you pick it up and the guy says, "Hi, this is Bob from IT." "Yeah, hi Bob. You don't know if Bob exists, do you? I mean, there are dozens of people down in the evil basement of IT or in the wherever they happen to be, and Bob says, "Yeah, I need you to go to your computer and log in, and then I need you to go to this website, and I want you to click on this button." Yeah, it's okay to install that. Great. Okay, thank you very much. Appreciate it. Now I can move on to the next one. Okay, guess what just happened? You just downloaded a vector onto your computer, allowing a potential cyber criminal thief to to do their thing. Um, Social engineering is used in a whole lot more areas than just cyber threats. You'll often, if you're sitting in a company, if you're sitting at your desk, if you answer the phone, you'll often get a phone call from somebody saying, "Hi, this is Mary from purchasing. I need your P card so that I can order some office supplies for you." Okay. Mary in purchasing shouldn't need your P card, your purchasing card number. It's probably somebody committing fraud. You see emails all the time of, "Hey, this is printer supplies," and all kinds of other things. So social engineering can be done for so much more than just cyber threats, for lots of criminal activity. Just as an aside, notice that I'm not using the word hacker in describing these people. These people are cyber criminals. They are thugs. They're they're violent criminals, just as they're criminals. A hacker, if you go back to the historical definition of a hack or a hacker, was actually a badge of honor and a badge of pride issued in the 1950s, 60s, and 70s in the early days of computing. So I won't use the word hackers when talking about cyber criminals. Cyber criminals are evil, malicious, nasty thugs that need to be stopped. Hackers are guys like me that are really interested in tech and do cool and interesting new things. So just want to make sure that at least you've heard that definition, and that's why you don't hear me referring to these bad guys and gals and people and organizations as hackers. So we've talked about the crimes, we've talked about the vectors, we've talked about what they're doing and how they're trying to do it. How do we stop them? There's a whole college degree here at this university on how to stop cybercrime and cybersecurity. So I'm certainly not going to go into any kind of detail, but you really do need to understand some high-level safeguards. One of the things we will use to safeguard and to make sure that people are who they say they are is biometrics. Um, I don't know, my smartphone here unlocks when it sees my face. I just look in the camera and it sees my face and automatically unlocks using biometrics. My previous phone had a fingerprint reader on it that I just put my finger up to the phone and the phone unlocked. That's kind of nice. There are voice systems. There are even gate systems that watch how you walk and decide whether you are the person you say you are. There are multi-factor authentications using secure keys with security things on them, using random number keys. Some companies issue little key rings that display a random number. There's the Google Authenticator app on your phone. Some sites will send you a text and you type in a 4 to 6 to 8 digit number. Some sites will call your phone to make sure it's really you. So multi-factor authentication is one of the safeguards. There's another safeguard that we use to safeguard our network called a firewall. And basically what a firewall does is it sits between the public and your private network, and kind of sits in between, so that all of the network traffic from outside passes through the firewall before it gets inside, and all of the traffic inside passes through the firewall before it gets outside. And you can see that in my little sketched up diagram here. There are three different kinds of firewalls, kind of configurations. Firewalls can be set up to filter network packets by network address, origin, destination, and maybe some content. Some of the firewalls are built around applications that allow some applications to access but other applications not to, like HTTP on port 80. The web server data can flow but other data can't. And then there's another type of firewall that uses a proxy server, which hides the internal from the external. You'll learn more about that in your networking courses. There's another piece of software or hardware that and a firewall can be a software firewall or a hardware firewall. There's another piece called the intrusion detection system, or IDS, and it sits between the public and the firewall. It sits connected directly to the pipe coming in from your various internet service providers directly to your network connections. And what it does is it blocks suspicious traffic before it ever gets to the firewall. So if a denial of service attack is coming in, it stops the denial of service. It stops those incoming packets before it even gets to your firewall, before it can bog your private network down. So an IDS kind of sits between the public and the firewall, and that's what that little green arrow is supposed to mean. Another safeguard would be just access control. Cable locks on your computers, door locks on your server rooms, ID badges. And these are done to eliminate and to keep from someone walking away with a piece of hardware, walking away with a hard drive, walking away with data, or misuse of company resources also. Some additional safeguards that you can implement are auto log on and log offs, or auto log offs and locks, so that if your computer sits inactive for more than 3 minutes, it automatically locks itself, requiring a password or a biometric entry to get back into it. Well, that keeps somebody from tailgating onto your desk, because you've logged in, you've got your computer up, everything is groovy, you just went out to get a cup of coffee real quick. That keeps somebody from sitting down at your desk, using your user ID, and getting up before you come back. Password security is another safeguard, but password security is a human thing. Humans don't like to remember passwords, don't like to remember long passwords, and password security is problematic and not very secure. Most users have 2 or 3 passwords they use for every service and every site. Is your Amazon password the same as your eBay password, the same as your bank password? If so, it won't take much for me to own you. That's just because if you use that password at a not quite kosher site, and they happen to get your user ID and password and can associate it to your other accounts, then I own you. You really should use a different unique password for every single logon. And you're going, oh my God, how am I going to do that? How in the hell could I possibly do that? Well, I'll give you a little hint. I personally use a program called KeyPass for my smartphone. It's called KeyPass 2. That has one master password that I use for nothing else except KeyPass, and then it stores all of my user IDs and passwords in an encrypted database on my Dropbox. There are lots of those password safe and password security systems, but I literally have a different password for every single service I use. If you got one of my passwords, you don't own me yet. It's going to take a little bit more than that. Unless, of course, you got that one KeyPass password, and then you own me. But I don't use that password anywhere else except on trusted computers that I've loaded KeyPass And there are lots of different password safes out there that are good, but that's just the one I use because it's free and open source. Um, there's another safeguard known as a virtual private network. And actually, it's not really a safeguard, but it's one of the ways that we can extend our private network to employees or to customers outside of our direct control. So, a virtual private network, or VPN, allows us to create encrypted data that's tunneled from one network to another network. The encryption techniques are typically L2TP or IPsec, which are the two most common encryption techniques. But what this allows for is remote users to have secure access to resources within our network. For instance, when my wife works from home, her laptop, she uses a VPN which ties her laptop to her corporate network that then will allow her to use terminal services and remote desktop to remote desktop into her computer at the university. So by creating that connected virtual encrypted tunnel, it extended the corporate network into an extranet. It's low cost. The packets are a little slower because they've got to be encrypted and then decrypted on both ends, but it's not that big of a deal. And it's low cost, it's easy to set up. Now, one problem is there is no real standard. It's vendor specific. So if you're buying Cisco's VPN or if you're buying VPN from another server, another provider, the client software you have to load on your computer and the software you have on your routers and firewalls is proprietary to whoever you bought your VPN through. But most organizations have got some form of this, and it works really well. In the last slide, I mentioned encryption because I said there was an encrypted tunnel between two computers. Um, in encryption, there are a couple of terms that you need to know, and one is called the plain text or clear text. And that's the text that we're wanting to encrypt. And the ciphertext is the encrypted version of that text. So, I type in a message in plain text. Professor Renault is an evil jerk. That's the secret message, and I want to send it over to someone over on the other side, but can't let Dr. Renault know that. I said that about him. So I'm going to encrypt it, and then I'm going to send it over to my friends somewhere else, and they'll decrypt it. There are two basic forms of encryption. There's one known as symmetric encryption and one known as asymmetric encryption. Symmetric encryption, both parties know the same key. You use a key to lock the door, to encrypt the text, and you use the very same key to unlock the door. Makes sense, doesn't it? Now, one of the problems with symmetric encryption is that every pair of individuals need to have a set of one shared secret. And sometimes sharing that secret key is difficult because maybe you're on the network. And how do I send you a secret key and keep it secret? Because I've got to send you the key in a way that you can decrypt it. But if we don't have a key shared, then so I've got to send it to you in plain text. So sharing a symmetric key can be difficult. And if that key happened to get broken, then all of the data encrypted using that symmetric key is now broken. The other general technique used is known as an asymmetric key. And in an asymmetric encryption, there are two keys for each person, and each person has two unique keys. I've got my two keys, you have your two keys, that other person has their two keys. And one of the keys is known as the public key, and one of the keys is known as the private key. So, to encrypt something, I use the private key, or I use one key to encrypt, and the other key to decrypt. Okay, so if I use the public to encrypt, I use the private to decrypt. If I use the private to crypt, I use the public to decrypt. So how that's used is here in this diagram, here in this colorful diagram. So I've got two people. I've got a sender and a receiver. And the sender wants to send secret text or a secret message to the receiver. Well, the sender knows three things. The sender knows their private key, their public key, and the receiver's public key. The receiver knows three things. Their private key, the receiver's private key, the receiver's public key, and the receiver also knows the sender's public key. So what happens is the sender does the first thing and uses their private key, which is that blue circle with the yellow. That would be the sender's private key, and encrypts the text once, and then encrypts it a second time using the receiver's public key. Okay, so the ciphertext gets sent through the network, and the receiver then says, oh, well, I decrypt it with my private key because he encrypted it with my public key, and then I decrypt it with his public key because he used his private key, basically unwrapping the packages, and I get the plain text. By encrypting it twice on both sides, by encrypting it twice and decrypting it twice, using a combination of the public-private key, I know that nobody has looked at it in the middle. No, because I've got to have all three keys to get to my data, and I know that it was sent from this person because I used their public key to decrypt it. So that's really interesting. And to make this work, everybody needs to know, or everybody who's in a sharing arrangement needs to know all the public keys, but only their one private key. I don't want your private key, just your public key. There is an idea and a group of companies out there that do PKI, or public key infrastructure. And basically what that is it's a trust authority that issues these key sets, public keys and private keys. When you use HTTPS, the secure socket layer of HTTP, it uses this type of encryption to encrypt the network packets going from your web browser to the server, and from the server back to your web browser. There's also another implementation of this known as TLS that's used in email transmissions, so that the email goes from one server to another in an encrypted manner, so that the server knows it came from the server that it was supposed to, and it received only by the server that's supposed to receive it. So we've talked about threats, and we've talked about vectors, and we've talked about some things we can do to eliminate these threats, encryption and all. Now, how do we handle this? Well, one of the common models used by business and used by businesses is called a zero trust security. Basically, we trust nobody. In a zero trust, creating a model of zero trust means that every person and every device must be secured, whether it's in the network or outside the network. If it's going to talk to us, it has to be secured. We have to issue the lowest privileges possible to each individual user, and only allow users to see what they have to see to do their job. For instance, if you're working as a cashier at McDonald's, you know how to run the register, but you don't know how to do free food, because that's a manager responsibility. So you see, they've given you the least possible access to do your job. Microsegmentation is another thing that's part of zero trust, where we segment the network into a small section and say, well, only people who can do this thing are in this segment of the network, and over here's another segment of the network where people can see this other data set. And there's another set of the network where only people can see another part of the data set. So by segmenting the larger enterprise and segmenting the larger network and systems into a group of smaller systems that we can then control, and then using multi-factor authentication to make sure that it's you and not somebody else who just happens to have your password. So it's a little difficult to do this in practice, but it's really what most organizations are doing is looking at this zero trust model when they're analyzing their security systems. Something that we haven't talked about that we really do need to talk about, though, is in context of security and systems availability, is business continuity planning. We have to also not only plan for a network attack or a cyber attack or ransomware or something of that sort, but we also need to plan for a natural disaster. What happens if a tornado takes out your corporate headquarters? What happens if a flood takes out your corporate headquarters? What happens if your network connection goes down because some idiot with a backhoe just cut the fiber optic cable to your building? And it's going to be 3 to 5 to 7 days before you can get your continuity, your data back up. So be sure to have a plan of what's going to happen if something happens, because something will eventually happen. Natural disasters, things happen. Backup. Be sure to have regular backups. If it's going to hurt to recreate the data, back it up. If you've spent more than a few minutes, back it up. Save it somewhere. Save it off site. Get it out of there. Train for business continuity. Train your network people, your cyber people, even some of your end users how to deal with the company if we were to have a natural disaster or a huge network attack. Test. Mock drills and drill and make sure you can do it. Make sure it's going to work. Make sure your plan really works. And off-site, at another site somewhere, most companies now are doing this with a cloud provider, encrypting the data, encrypting the organization, encrypting the backups, and putting them on a cloud server. But also, in addition to having your backups out there, have your plan for how you're going to do it. Because if your plan was in the network that just went down, well, then you don't have a plan, do you? So be sure that your plans are off-site as well. Some organizations have what's called a hot site, where they literally lease or own a computer system that's running a live backup and actually a full duplicate of their data servers and of their data that they can switch to in a matter of seconds. Literally just flip a switch and the network then starts routing things differently. Or other organizations that don't need to have 100% or 99% availability may use a cold site, which is, well, we know our data's off-site. We can go get us a cloud server quickly and get the data up within 6, 12, 18 hours, and everything's going to be okay. So that's a question that you have to ask in any business continuity planning. And I hope in your other business classes you'll talk about business continuity planning. How long can you go without? How long will your business survive without? Computers, phones, data, web, all of those things. It's important. to plan and to know that these things can and will happen. So in a previous slide, I mentioned having a comprehensive security system, but I want us to think about a comprehensive security system in terms of four actors, four broad groups of things that I need us to look at: humans, hardware, software, and networks. Comprehensive security has to include all four of these areas. And if we don't include all four of these areas, we're potentially running into, we've left ourselves open to lots of vectors. Humans, training, awareness, password policies, managing access. So when an employee leaves the company, we yank their access immediately. Or when we hire somebody, we give them access to just what they need. So we need to manage the access, limit the access. We need to audit the access. So there's the human side. There's the hardware side. We need to inventory our hardware. We need to audit our hardware. We need to secure our hardware and make sure it doesn't walk away. Or we need to remove disable ports or other things so that we know that our hardware isn't doing things it's not supposed to do. We need to worry about the environmental conditions that our hardware is living in: air conditioning, flood resistant, natural disaster resistant, concrete walls, concrete bunkers, whatever. All depends on how important the hardware is, but the hardware is an important component. And then when we get rid of hardware, we don't just put it in the dumpster, because we've got dumpster divers, don't we? So before that hardware leaves our control, it needs to be securely destroyed or wiped. I know at the university, before they sell a computer that was on a faculty's desk or a computer that was in a student laboratory, they remove the hard drive and literally crush it. Physically put it in a crusher and crush it, so that there's no way the data is ever going to come off of that hard drive. Wow, that's pretty ridiculous. Then they sell the computer with no hard drive in it. And if you want to do something with it, you have to. But that's important. Think about that network router that you just threw away. Well, is there a way I can hook a terminal to that network router and possibly see your network configurations? Maybe. So be sure to destroy and wipe appropriately any hardware that's leaving the organization. Software. Patch it, update it, audit it. Make sure you know what's on everybody's desktop, what they're running. Use the book publisher suggests using licensed software. I'm a big open source fan, but knowing what's on knowing what's on the computers, knowing what they're using, as well as then patching and updating it to make sure that if there are any cybersecurity threats, they're fixed as soon as possible. Makes sense, because that's another vector for fraudulent and malicious users. And then the networks themselves. Using an intrusion detection system, using a firewall, patching and updating the software on your routers, your firewalls, your IDSs, your switches, and all of those things. Monitoring network traffic, and the logs that go along with all of the network traffic. Auditing the logs and the hardware and the software and the humans to the actual billing from your internet providers, to make sure there aren't pipes that you are paying for that you didn't know and aren't included in your firewalls. Maybe somebody's gone around and bought their own, or running network searches for hardware that you don't recognize. You know, your employee over here needed another network port. So instead of contacting information systems, the IT people, they just went out to Office Max and bought them a router, plugged it in, gave them a few extra network ports. But wait a minute, that just opened up a whole bunch of holes, didn't it? So knowing what's on your network and knowing what's there is extremely important as part of a comprehensive security team system. You need a team and a full buy-in from upper management, middle management, low management, from your IS people, from your cybersecurity people, from your insurance agents, you need a full buy-in for this comprehensive security system from everybody. And it takes time and it takes education, but it's well worth it, because your organization is going to be a whole lot less likely to be held ransom or suffer from significant cybercrime or cyber loss. This concludes my video for Chapter 5. Thanks for watching. Glad you suffered through another one. Remember, most underutilized resource on a college campus are professors' office hours. Go see them. Contact them. Let them know. If you have any problems, let us know. That's what we're here for. Read the syllabus. Read the book. Don't be evil, and all that other stuff. Send any questions to me at jrenault.shawnee.edu, and I'll see you next time. Bye.